Hello students, today we are going to see about the NPTEL week 2 assignment and the topic 8086 pins and signals in the subject microprocessors and interfacing. So the first question is, in order to read a word from the memory location 6000 CH in a single bus cycle, the status of 8086 signals A0 and BHE bar is. So here we are going to read a word from the memory location. So whenever it is a word, both A0 and BHE bar should be 0. So we have 4 different cases, BHE bar value 0 and A0 value 0, and both values are 0, 1, 1, 0, 1, 1. So according to the values, either it is a word or upper byte from the memory location or lower byte from the memory location or no operation, it is given by according to the values of A0 and BHE bar. So here both the values are 0. If both the values are 0, then 8086, the status of 8086 is such that it will read a word. So the option is first option. Second question, if Bx equal to 00A0 and Ds is 2000H and also one memory location is physical address is given, in that physical address we have the value 80H, another physical address is given where we have 08H and Cx value, offset value Cx, in Cx the value stored is 5000H. So what happens whenever we have the instruction move Ch comma, you have within the braces Bx. So this is the register indirect addressing mode. So that is the address is given indirectly by the register Bx. So whatever the data available or pointed out by that offset address will be transferred to Ch. So after the movement of value offset address, the data available in the offset address to Ch, what will be the output of the Cx value? So that is the question. So here actually first we need to find out the address, physical address, that we need to find out. So what is the physical address formula? Physical address is given by segment register into 10 plus offset value. So this is the general formula. So here the segment register, what is the segment register? Data segment. Since we are going to transfer the data, segment register is given by data segment. So data segment value is 2000. So 2000 into 10 plus what is the offset available? The offset address is given by Bx. So what is Bx value? 00A0. So when we add both the values, it will be 200A0. So this is the physical address. So from this physical address, whatever the value available will be moved to Ch. So according to the instruction. So what is the value at this address? At this address I have 08. So 08 will be moved to Ch. So they are asking to find out the value of Cx register. So already they have given what is Cx. So Cx is previously it is given by, previously the value of Cx is given by 5000. So now after the execution of this instruction, the Ch value alone is changed. So 50 now becomes 08. So now the value available in Cx is nothing but 0800. So the option is third option, that is 0800. Before the execution of pop instruction, the stack pointer points to FFFH, the content of the stack pointer after the execution of pop instruction. So actually we have two things, push and pop. Push means we have to decrement the stack pointer by 2. Pop means we have to increment the pointer by 2. So they have given that FFFF. So after this, if you increment the next position, it becomes rollover, it becomes 0. So it is 1 increment plus 1. So again it will be incremented, stack pointer will be incremented by 2. So again one more increment will be there, so this value it will become 1. So stack pointer, previously it is FFFF. So now because of pop operation, stack pointer becomes SP plus 2. So now the value it becomes 0001. So the answer is third option, 0001. Which of the following is not a maximum mode signal of 8086? So maximum mode, it is not a maximum mode. So ALE comes under minimum mode. So the option is third option, ALE, address latch enable, which is not a maximum mode signal. Other things, lock S0 bar, Q S0 comes under maximum mode signal. The number of T state present in bus cycle of 8086. So here for 8086 it is 4. So the option is third option. The number of T state present in each and every bus cycle it is 4. Which of the following signal of 8086 is used to demultiplex the address and data bus? So in order to demultiplex, we require the signal called ALE, address latch enable. So the address latch enable is used to demultiplex the address and data bus. So actually in order to reduce the number of pins, address and data both are multiplexed fashion in multiplexed fashion in the pin diagram of 8086. So in order to demultiplex, we require the signal called address latch enable. So the option is second option. Last instruction of subroutine would be. So generally the subroutine is called by call, and the last instruction of subroutine always it will be of return. So RET. So the option is third option, RET. Suppose if it is interrupt, then the last instruction will be interrupt return, IRET. So generally if it is a normal subroutine, the last instruction it will be return instruction, RET. The stack operates on the principle of, so it is last in first out. Stack operates within the principle of last in first out. If it is queue, it is first in first out. Stack means last in first out. Which of the following 8086 signal is used in direct memory access data transfer? So direct memory access means in 8086 we have two things, that is hold and HLDA. Okay, so hold means to give the request to the 8086 to access DMA, we use hold signal, and to give the acknowledgement of DMA access we have the signal called HLDA. And which of the following is the interrupt signal of 8086? So interrupt, here in 8086 we have two signals, two interrupts which is given through the pin, that is NMI and INTR. So the option here it is NMI, non-maskable interrupt. So one more interrupt is there, it is INTR. So with this the week 2 assignment is over. Thank you. Thanks for watching.